Good evening. My name is Dr. Daryl Boyd, and I'm coming to you on behalf of the Transformational Education Adventure Center, also known as the T-Center, which is located in McLean, Virginia. Tonight, you're going to learn about a STEM lesson. So, for today's STEM lesson, we're going to learn about sound, and here's what you'll need if you want to follow along. You'll need 2 paper cups. You'll need a piece of string that is at least 5 feet long, all right? And these are not necessary, but I find them handy. You're gonna need 2 paper clips, all right? Again, 2 paper cups. You can also use plastic, but I think paper tends to work the best. A piece of string that is 5 feet long and 2 paper clips. Okay, so sound. What is sound? What is sound? Well, sound actually travels in waves, all right? And that's how we're able to detect it. Now, sound travels differently in different mediums. When I say medium, I'm talking about a solid, a liquid, or a gas. Why does sound travel differently in the different mediums? Because the molecules are either really close together, like they are in a solid, or they're very far apart, like they are in a gas, or somewhere between, like in a liquid. So, sound travels faster when the molecules are closer together. That means that in the air, sound actually travels slower than it does in water. And in water, sound travels slower than it would in a solid. All right? How fast is sound? How fast is sound? Okay, well, sound travels roughly 340 meters per second, plus or minus 20 meters per second. Okay, meters per second may not be a unit you're familiar with, so I will convert it for you. Sound travels roughly 770 miles per hour, and that's pretty fast, okay? But sound is not the fastest thing that we know of. Light is much, 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 much faster than sound. Now, human beings have devised ways to actually travel at the speed of sound. Most cars can't travel that fast, but there have been a few specialized cars that have broken the sound barrier. Airplanes, however, they get pretty close. So a commercial flight going from New York City to Los Angeles, California might be going about 550 miles per hour, which is pretty close to that speed of sound, 770. And the military, they have some very fast jets. Those jets can actually go faster than the speed of sound. In fact, some of the jets can go way faster than the speed of sound. And when they go by, because they're going so fast and they're going faster than the speed of sound, they make what we call a sonic boom, like a cracking noise. All right, it's pretty cool. So you'll see the airplane first, and then 10 or 15 seconds later, you'll start to hear the airplane. And that's really, really awesome. Well, we're going to make sound travel through a solid medium. What is that solid medium? Sound is going to travel through a piece of string. Here's how here's what you'll need to do. First, you'll need to poke a hole in the bottom of your cup. All right, poke a hole in the bottom of your cup. Do the same thing to your other cup. Poke a hole in the bottom of the other cup. Then what you'll want to do is take a piece of string and pull it through that hole, all right? So this is what it looks like there on the inside. When you pull it through, you'll want to make a knot at the end of the string. Now, I have taken a paper clip and I've actually tied a knot around the paper clip using the end of the string. That way, I'm pretty confident that I can't pull the string out of the cup. All right, I've done the same thing with my other cup using the same string. All right, so I have one piece of string that is now tied to a paper clip in one cup and also tied to a paper clip in the other cup. And that's what it looks like. So how do we test this out? How do we know that this works? Well, here's what I would recommend. Find a friend, a parent, a sibling, have them take the cup and you take the other cup. One of you stays in place while the other person walks slowly away, all right? And you want to walk all the way until the string is straight and tight like this. You do not want your string to be like this and drooping, all right? If your string is drooping, you won't be able to hear. If it's straight and tight, you will be able to hear, all right? That's very important. Okay, so as you have walked and separated out and now you got your long string straight and tight, one of you is going to speak and the other is going to listen. Now, don't speak too loud. That will defeat the purpose because then the person on the other side listening will be able to hear you not through the cup, but through the outside of the cup. And that's not what you want. But talking to the cup and the other person hold the cup to their ear and listen. Will it work? Give it a try. Now, I will tell you it should work. If you made your cup as I've described, it should work. Interestingly, this cup, one cup, serves two functions. The cup serves as the microphone for the person who's speaking into it. It also serves as the receiver for the person who's listening. It's just a matter of if the cup is being used to listen or to speak at that time. All right. Now, here is a challenge question. And I want you to come up with a hypothesis before you try it out. Remember, a hypothesis is a prediction or an idea or a guess that you can test. It must be testable in order to be a true hypothesis. So, if you have your string and it's straight, all right, and you have a friend on one side and you're on the other side, but then another person, let's say your pesky younger sibling, comes up and grabs the string right in the middle and pinches it like that while it's straight. Will you be able to hear, if you're listening, a person who's speaking into the other cup? Give it a try. Tell me what your results are. You can also try taking the same string and bending it around a corner, like maybe the corner of a door or a wall. One person speaking into it, the other person listen. Are you able to hear? If you're able to hear, are you able to hear as well as when no one was pinching the string in the center or when the string was straight and not bent around the corner? All right, what do you think? Write down your hypothesis, then test it out. All right, that is our lesson for today. I hope you enjoyed it and I will see you later.